of it. So, all right, so we're talking about finding what scaled copies there exist for the original triangle O. Now, what we notice here with this original triangle is that it does have a right angle inside of it. So that means that this is technically a right triangle because of the fact that it does have that right angle inside. It's also called a scalene triangle. What makes it scalene is the fact that it has all three side measurements being different. So you have your base measurement, that's a 3 in this case. We have a height measurement, that's a 4. And then because this is a right triangle, it has a very specific term for this diagonal measurement. It's called a hypotenuse. And so the hypotenuse happens to be a different measurement. So all three side measurements are different, so that's why we call it a scalene triangle. If they have 2 equal sides, we call it isosceles. If it had all 3 sides being equal, then we call it an equilateral triangle. So there's different kinds of names that you can give for your triangles. So right off the bat, knowing that I have to look for a right triangle and that the right triangle has to have all 3 different measurements, who can raise their hand and tell me what are some triangles I can automatically get rid of because they're not right? What's a triangle up here that's not a right triangle that I can get rid of? AJ? A I can get rid of because it's not a right triangle, so automatically I know it's not a scaled copy. What's another one that I can automatically get rid of? Michaela? F is not a right triangle, so I can automatically get rid of that. So all the rest of these are right triangles. So now I want to look for anything that's not scalene, meaning that it doesn't have all 3 sides being different. So are there any right triangles up here that don't have all 3 sides being different? Andrea? H. H is an isosceles triangle. It has 2 equal sides. That's not going to work. So automatically I can get rid of that. So I've eliminated 3 options. That means there's only one more option up here that's not considered to be a scaled copy. So from here, that's where I have to actually do the math. Now, if we're looking at B, B is a scaled copy because it's identical, isn't it? Right? It has a measurement of 3 compared to 3. If I take this 3 and I divide it by 3, what am I going to get? What's 3 divided by 3, guys? 1. Okay? If I take the height is a 4. If I divide it by its original 4, what's that going to give me? 1. And if I take the hypotenuse, this hypotenuse is a 5. If I divide it by its original 5, that's going to give me a 1. So do they all have the same scale copy or scale factor? Yes. They all have an identical scale factor, and the scale factor is going to be a 1. So that makes it a copy. So triangle B is going to work. The original measurements compared to the new measurements, we've got 3, we've got a 4, and we've got a 5. And when we divided 3 divided by 3, 4 divided by 4, and 5 divided by 5, it gave us a scale factor of 1. Okay, let's take a look at the next one. So for here, if I take this 2, if I take the 2 and divide it by the original 3, what's 2 divided by 3? Not 1/3, just 2/3. 2 divided by 3 is going to equal 2/3. Now if I take the height is 5. What am I going to have to divide the 5 by? 4, right? We have to divide the height by the 4. So if I divide that by 4, is that going to be the same thing as 2/3? Is 5 over 4 the same thing as 2/3? No. Those are not equal to each other. They are not equal to each other. 5 over 4 and 2 over 3 are not equal, so therefore C is not going to work. That means the only triangles remaining are actually my scaled copy. So I can go ahead and fill that in. I've got triangle D, triangle E, and triangle G. Let's go ahead and fill that stuff in. So for D, I have a base of 3 over 2. If I take 3 over 2 and divide it by 3, I'm going to get 1/2. I have a height of 2. If I take 2 and divide it by the original 4, that's going to give me 1/2. And if I take the hypotenuse, which is 5 over 2, if I take that 5 over 2 and divide it by its original was 5, that's going to give me 1/2. Okay, so that means all of these are the same. There's my scale factor, 1/2. Let's now do the same thing for triangle E. Triangle E, we had a, oops, I highlighted in the wrong color, my bad. I have a base measurement of 6. What am I going to divide the 6 by? Again, 3. We're going to divide 6 by 3. That's going to equal what? What's 6 divided by 3? 2. Okay. We have a height of 8. What am I going to divide the 8 by? 4, right? Because the original was 4. We're going to divide that by 4, and that's going to equal what? 2. Then we have a hypotenuse of 10. What are we going to divide it by? 5, because the original was 5. So we're going to divide that by 5, and that's going to come out to what? 2. Okay, so that means our scale factor is what? 2. There's our scale factor. Our scale factor is 2. Okay, let's do the same thing for G. G, we had a base of 2. What are we going to divide the 2 by? 3, right? Because it had an original base of 3. We're going to do 2 divided by 3. 2 divided by 3 is just going to equal 2/3. Okay, we have a height of 8/3. We're going to divide that by 4. 8/3 divided by 4, that's going to equal 2/3. Then we're going to take our hypotenuse. Our hypotenuse was 10/3. We're going to take 10/3 and divide it by 5. That's going to come out to 2/3. So what's our scale factor? 2/3. Okay, so there's our scale factors. Any questions? Okay, what you are going to do now, we are going to go through each of these problems. We've got 4 problems. You're going to get to work with a partner. You need to read each of these problems carefully, and you're going to choose yes or no, that's true or it's false, what they're saying. And then you need to justify it. You need to show your work that justifies why you're saying it's true or it's false. You're going to do that for all 4 problems. You got 10 minutes. 10 minutes, and then we're going to go over it. Everybody clear? Get with a partner. Go. All right, let's take a look. Problem number 1. For problem number 1, it says the large robot shown below, the large one, is a scaled copy of the small one because each slide length is multiplied by itself. So they're saying that that's what makes it a scaled copy. Is that true or false? False. Why is it false? Scale copies are scale copies because it's multiplied by the same scale factor, not multiplied by itself. That's the issue. So let's take a look at what I'm talking about. For here, we have the measurements for the base. If we're taking a look at the big rectangle has a base of 16. If we divide it by the original base of 4, that's going to give us a value of 4. Well, now if we do the same thing for their heights, or sorry, not their heights, but their top base. Taking a look at the top base of the large rectangle, that's a 9. If we divide it by the original, that was a 3, that now becomes a 3. So are those the same scale factors? No. Okay, and you can check it again with the other measurement that they gave. The other measurement was right here, that little tiny value of 1. If we take the large rectangle of 1 and divide it by the small rectangle of 1, we're getting a value of 1. None of these are equal to each other. They are not equal, and therefore that is not a scale factor. Scale factors have to be equal. Write that down. Scale factor must be equal. Since it is not equal, it is not a true scaled copy. Okay, being multiplied by itself means nothing. Scale factors need to be the same. All right, go ahead and flip it on over to the back. So for the back, they're saying for problem number 2, it says the larger triangle will become a scale copy of the smaller triangle if the vertical height is changed to 12.5. So they're saying right now, as is, it's not a scale copy. But if you were to change this 15, cross it off, and make it a 12.5, then that will now become a scaled copy. Okay? So if we change the vertical height to 12.5, that will make it a scaled copy. So let's check and see if that's true. We're going to start off with the base of a 20. What do I need to divide the 20 by? By 8, right? That we have to divide it by the original. 20 divided by 8 becomes 2.5. Okay, now I'm going to do the same thing for the height. My height is now 12.5. What am I going to divide it by? 5. The original height of 5. 12.5 divided by 5 is 2.5. Okay, so we're good so far. Now we're going to do the last thing for the hypotenuse, which was 5. What am I going to divide 5 by? 2, right? Because the original had a hypotenuse of 2. And 5 divided by 2 is 2.5. So is that a scaled copy then? Yeah, right? All of these are equal to each other. These 2.5s are all equal to each other, so it does have a scale factor. Scale factor means it is a scaled copy, so it's true. Okay, let's take a look at problem number 4. This is my fault. I should have told you guys. This is the green. This one's the green. This one's the blue. My apologies. Okay, so they're saying that the green triangle is a scale copy of the blue triangle, and it has a scale factor of 3. Okay, so let's take a look. If we take a look at the measurements, let's start with this 9. I'm going to take 9. What do I have to divide the 9 by? 6, right? The 9 and the 6 are going to be corresponding with each other. 9 divided by 6 is going to come out to 3/2. Okay, if I do the 12 on the green, what am I going to divide the 12 by? By 8, right? 8 on the blue. When I divide those out, that becomes 3/2. Then I'm going to do the same thing here. On the green, I'm going to take 15, and I'm going to divide it by what value on the blue? 10. And if I do 15 divided by 10, that's going to be 3/2. So is it a scaled copy? Yeah. But is this true? No, because what they say the scale factor is going to be 3. So this is the part that makes it not true, makes it false. Okay? It is a scaled copy, but this is not the same as 3/2. Okay? 3 is not equal to 3/2. So that's, even though it is a scale copy, they're saying it's a scale copy with the wrong scale factor. Okay? So write that down. Wrong scale factor. That's the only reason why it became false. Because the scale factor was not what they said it was going to be. Okay, and let's take a look at the last one. They're letting you know that the green polygon is a scale copy of the blue. So this is our green. This is the green scale copy, or a polygon. This is the blue scale, or the blue original. They're saying that they are scaled copies, so we want to know what these measurements, these missing measurements will be. So if I know what my scale factor is, I can take my scale factor and multiply my old one to become my new one. So I know that here originally I have a 7.5 that can be divided by a 2.5. If I do 7.5 and divide by 2.5, I get a scale factor of 3. That's my scale factor. And I can even double check it just to make sure that all that's the same. If I take this measurement of 15 and I divide it by this measurement of 5, again, I get the scale factor of 3. Okay, so my scale factor is 3. Now all I have to do is just multiply by the scale factor. I just have to multiply by the scale factor. So I'm going to take this old measurement of 1.5 and I'm going to multiply it by my scale factor of 3. And I'm going to take this old measurement of 6 and I'm going to multiply it by 3. Okay, if I do 1.5 times 3, that gives me 4.5. So I'm saying that this is going to become 4.5. And if I do 6 times 3, that's going to become 18. So I'm saying that this measurement is going to be 18. Is that what they said was going to happen? Let's check. They said that it's going to be 4.5. That worked. They said it was going to become 18. That worked. So this is a true statement. Okay, you have no homework tonight.